determine the interval on which f is concave up. There are so many methods, guys. To concave up, actually, you're forming your mean. Okay. And then to concave down, you'll form your max. Concave up. So what I prefer is one thing. To concave up, just know that for any point on that concavity, any point, then the second derivative must be greater than
0.
That is the formula. When something concave up, the second derivative is always positive. If it's concave down, the second derivative is negative. Just that formula. What you need to do is 4 marks, yes, it's 4 marks, because your first 2 marks will come from the first derivative. The first derivative, hop down, 3x to the power of 2 plus 2x and then minus
1.
This is your first derivative. You cannot use the formula yet. We need the second derivative. So the second derivative is from here. That is
6x
plus 2. Now I can say, fine, 6x. Remember, you have 1, 2, 3. Maybe, yeah, it's a lot, man. You can. Maybe 1, 2, 3, 4. So 6x plus 2 is greater than
0.
Because it's my second derivative must be greater than 0. Okay, don't include it. You're just concaving up or down. Don't say equal to 0. So once you say equal to 0, it means you're looking for the point of inflection as well. Okay, so the point of inflection is actually the point of reference, but it's not actually what we want. So x, do you agree, class, is minus 2 over that?
2 over 6.
Minus 1 over 3. X is only greater than minus 1 over 3. And then set builder, x an element of?
So minus
1
over 3
to infinity. I mean, that is an interval form. Let me write properly. This is set builder. And then the interval form, x an element of, it doesn't want to write element. X an element of equals.
Shall I just try for you?
Yeah, try with that hand.
Okay, so x is an element of?
Negative
1 over 3 to infinity, and neither of them are included, so round brackets.
Let's see if we have both of them, or one, or maybe interval.
So it's
just only one.
Yeah.
They only used that. Do you agree?
Yeah.
Don't include it. Just A.
Okay.
Okay. Now that was, we're still under calculus. Guys, concave up, second derivative. They can even say, use the second derivative to discuss the nature of the stationary points, either local max or local min. At your turning point, if you substitute that x value at the turning point on your second derivative and you get negative, it means it is a maximum. If you substitute another turning point in your second derivative and you get positive, it's your minimum. Second derivative is very useful, guys.